So inside of our diagram, we looked at how our web servers and our clients and our databases interact with each other. We talked about how that process is rather slow because databases store an enormous amount of data, making the retrieval process much more cumbersome. We talked about how a caching service can help make that faster. And here I want to discuss a bit about the differences between a database and a caching service. Now, they're both two forms of storage. I want to make that clear. A caching service and a database both store data. The difference, though, with a caching service is that a caching service prioritizes speed of retrieval over amount of data stored, where a database stores billions, maybe even hundreds of billions of entries in its data. A caching service stores significantly less. We're talking about hundreds of thousands or maybe low millions. It's definitely designed to store significantly less data. But because it's storing much less data, you're able to retrieve data out of it much, much faster. So in your system design, when you choose to use a caching service, you are doing so with the intention of storing high impact data that you need to pull out fast. Because again, you're not storing a lot of data in it, so you must be storing data into it with a very specific niche or very specific intention. So this is where something like region-specific data that is accessed significantly, much, much more, that is where you want to store it in a caching service. So going back to our example, web servers, again, apply business logic when it comes to the actual performance of what we're trying to get. Databases store and retrieve data. We can even say that it stores and retrieves all of our data. Our caching service caches specific data. So with this in mind, let's go back to our example. We know that we have our first North American user. So at this point, our caching service is empty. The first North American user requests the latest North American posts. Our web server then applies business logic, and it knows that it needs to retrieve these posts from the database because the caching service is empty. So it will go through that process no matter how long it takes. We're trying to retrieve these posts from our database. Our database, of course, knows its function is to store and retrieve this data. It will then retrieve these North American posts, send that back to the web server. The web server then applies more business logic that massages this data into the final format that our clients and browsers need. At this point, before sending it back, what it will do concurrently, meaning at the same time in parallel, it will send those North American posts to the caching service so that it can cache that data. Because now this work has already been completed. Our system, we know, these posts are most likely very high impact given the fact that the region is significantly large. There is a large amount of users that are going to want these posts. We don't want to repeat that work that we just did. So we're going to cache that data, and then the web server is going to send those posts to the browser client at the same time. Once this is done, the next North American user that makes that request for the latest NA posts. Here, the web server, again, has its business logic. And within our business logic is a check to see, hey, can I retrieve these cached NA posts? Meaning, check the caching service to see if these posts that are being asked for have already been cached somewhere. So this request goes to the caching service. And of course, as we know, our caching service does already have these NA posts. And then the caching service will send these posts back to the web server, but it will send a copy. Because again, we might be getting these requests to our caching service hundreds of thousands of times. So our web server will retrieve those NA posts and it will just send that back to the client. And we skipped having to go through that long and latency intensive process of communicating to our database. This is the main benefit of adding a caching service to our system. Now, you can add caching services to numerous steps inside of your system. The main idea with a caching service is that anywhere where you have to send any kind of data that is very labor intensive to do, maybe very latency heavy to do, you add a caching service because it significantly speeds up the amount of work. Caching services are everywhere, and they are very commonly used inside of your system design because interacting with a database is always, generally speaking, quite expensive in terms of time, especially for scaled out and distributed large systems that we're designing. So you will really want to utilize a caching service to speed up that process, because outside of reliability, availability and speed is one of the main things you're gunning for inside of your system design. Because now, through adding this caching service, we can see how for every other North American user that follows this one, within, of course, a specific amount of time, as long as that data is still relevant and the one that we want to send to the same group of users, we do not want to repeat that work. We want to just be able to retrieve it quickly from somewhere where we stored that already completed work of caching that data and then send it to every user that is requesting for it. You can see how this might be useful in numerous places in the system. So now that we understand caching, we of course will dive deeper into that as well later on, but you can see at a high level now how caching fits into our big picture of our system design. We've understood databases, we've understood caching services. Now let's continue with understanding more of our diagram.